My warm wishes to everyone. My name is G. Chandana. I'm graduating from Srinivas Ramanujan Institute of Technology, holding a roll number 234G1A0425, and I am from EC department. Today, my topic in this presentation is designing a 4-bit up or down counter using for loop in Verilog. So the topic is designing a 4-bit up and down counter using for loop in Verilog. So what is counter? Counter is a sequential circuit implemented via flip-flops. They are used to count the number of clock signals or pulse. A mode in counter will count from 0 to n minus 1. Counters can be synchronous or asynchronous. In synchronous counter, a single common clock is used for all the flip-flops, whereas in asynchronous counters, only a clock is given as input for first flip-flop. For an intermediate or final flip-flops, it clock pulse will be the output of previous flip-flops. So here you have a problem of designing a synchronous counter for sequence 0 to 1, 1 to 3, 3 to 4 and 4 to 5, 5 to 7 and from 7 to 0 using the T flip-flop. So the explanation will be for given sequence state uh, transition diagram as follows below. Here we have a diagram that is 0 to 1, 1 to 3, 3 to 4 and 4 to 5, 5 to 7 and also from 7 to 0. Here you can see state transition table logic. Present state will be 0. For the 0, next state will be 1 and for present state will be 1. For that next state will be 3. So if present state will be 3, so the next state will be 4. So present state will be 4, then next state will be 5. Likewise, present state will be 5, so the next state will be 7. If the present state will be 7 and the next state will be 0. So what is an up counter? An up counter increments its value on each clock pulse. It counts in binary from 0 to double one, double one, double one. That is 15 in binary is double one, double one. The counter resets to double zero, double zero from after reaching its maximum value. Here you can see the 3-bit asynchronous up counter. We used 3 flip-flops, that is JK flip-flops. That is, here we have 3 A, B, C. So logic 1 is given to all 3 uh, JK flip-flops and the clock pulse is given for only first JK flip-flop. So the output from the first JK flip-flop is given as clock as well as the counter output QA, and the result of second flip-flop is given as output QP and also clock pulse to the third flip-flop, and the output of the third flip-flop is taken as QC. Here you can see the state diagram, state table. For the initially we have given QC, QB, QA all zeros. For the down counters, it will be opposite to the up counter, that is 1 1 1. So the first down counter will be 0 0 1 and opposite to this will be the down counter. So all these values are same. If you see the uh, waveform for this up counter, so the waveform will be first the clock pulse will be 0 1 2 3 and this clock pulse will be taken from the table. So what is a down counter? A down counter decrements its value on each clock pulse. It counts in binary from double one double one, that is 15, to double zero double zero. The counter resets to double one double one, that is 15 after reaching its minimum value. Verilog basics for counters. Verilog is a hardware description language used to model electronic systems. It allows for a design of complex digital systems through simple constructs. For loops in Verilog can create repetitive structures making code concise. Overview of for loops in Verilog. For loops allow iteration over a range, simplifying a repetitive task. They can create or modify signals based on conditions set within the loop. This feature is particularly used in counter designs for efficiency. If you see, for loop is one of the most used loop. We use it to execute a block of assignments for a fixed iterations. Initial and stop conditions are mentioned to decide the number of iterations. If you see the syntax for loop, for and the condition start condition, stop condition, increment with the step. Next, designing the up counter. The up counter increments its value using a for loop, a trigger on edge clock edges. An initial value of clock is set and the loop increments until the maximum value. The counter resets once it reaches its maximum value, utilizing an if condition. uh, Designing the down counter. The down counter decrements its value using a for loop for triggering on clock edges. It starts from a maximum value and subtracts until it reaches 0. Similar to the up counter, a reset condition is used to maintain counter limits. If you see the example for loop using code, the following is a simple code snippet for a 4-bit up counter. So Verilog, as we give input and output, and next step is used always at the race post edge comma clock. So the next begin for loop start, here condition is taken that I is equals to 0. Initially I is equals to 0 and the condition is I less than 4, and the next step is count of I, that is count of 0 less than or equals to count of I plus 1. After applying this condition, so I is increment with 1, that is I is equals to I plus 1. uh, and then a for loop starts again. This will be ended if I is equals to 5. The condition will be false, so for loop will be ended. This code snippet demonstrates incrementing the code count array. Use appropriate reset logic to ensure the counter behaves as expected. So code, Verilog code for down counter. Here a simple code snippet for a 4-bit down counter. So input and output is taken comma, and next step is always at the rate post age comma clock. So next begin for initially I is equals to 0 and the condition is I less than 1. Here, so enter into the loop count of I less than equals to count of I minus 1. In the up counter, we use count of I plus 1. Here we use count of I minus 1. If the condition is false, the loop will be exit. This count snippet illustrates the decrementing behavior of the counter. Proper reset conditions must also be incorporated for correct functionality. So the conclusion and the applications of 4-bit up and down counters are essential in various digital applications. They can be integrated into large systems for counting, timing, and control. Understanding their design using Verilog enhances programming and design skills. Thank you for watching this presentation.